Well, hi and welcome to my shop this morning. I'm going to be continuing with this radio, or trying to figure out what's going on with the Magic Eye wiring and other changes that have occurred in the radio circuit changes that have been made. So it's been a few days since I've been in here. I've been off doing other things for about 3 days. So I thought maybe I'll just read through the comments, because they've collected a few on the last few videos, and just see what people are suggesting I do, in case there's a great idea there that I can make use of. So I wrote down a few of the comments. Okay, so obviously I must have counted pins backwards at some point, because I got 5 comments of people telling me to count the pins in the other order. Okay, no problem. I know which way to count pins. I just make mistakes, you know, like everybody. 5 wires on the Magic Eye. So let me jump in. I'm only going to go through a few comments here. 5 wires on the Magic Eye. 4 wires on the Magic Eye, okay? Someone wrote a very interesting explanation of how the dielectric and capacitors and other things that have electrodes sandwiching dielectrics, like cables and wires, how it really operates, or a much better description than what I may have tossed out here while I'm working. So thank you very much. Yes, the charge is held in the dielectric. It takes time to kind of soak in there because of molecular changes that are occurring, and it takes time to come out. So I'm going to tell a story about this. I'm going to tell a quick story about this. This happened 25-30 years ago when I worked at a power company. A big reel of communications cable had been delivered. So yeah, it's a power company, but I still use communications wires for things. So it's a cable about this big, and it's got 50 pairs of copper wires in it, each one of course separately insulated, like telephone. It's like a telephone cable, 50 pairs. So I showed up in the warehouse at the time this cable was being tested, and because I'm curious about this kind of stuff, I thought I'd come and I watched 3 guys doing this. One of them I knew quite well, and I doubted he really knew what he was doing. They brought out a high pot test set. Okay, so a high potential test set just generates a very high voltage, a little bit like this, but a little bit higher than that. And they went ahead and they took the cable, they cleaned off all the insulation from one end, they took the wires and separated them into 2 bundles, twisted the copper wires together in 2 bundles, and applied the high potential to it. I don't know, 15,000 volts I think they went up to. It took a long time to. It's a huge reel, and this is not this big. This is the size of a small car. I mean, this is one of these full-size cable reels with probably 1,000 meters of cable on it, or something like that. They finally got it charged up. I was some distance away watching. I wasn't involved in what they were doing. I was just watching out of the corner of my eye. They finished the test. They let the ends of the cable down, okay, with the 2 bundled up copper conductors, like 50 wires here and 50 wires here. They just let it go down. Then a guy came over with a screwdriver, and he whacked it onto the wires, and there was one heck of a bang. Bang! And everybody walked away. Now I already knew at that time that that would not discharge the insulation properly. And I also knew that the charge would build up. But I was 23 or 24, and these guys were 50 and 55. And I'm going to walk over, a fairly new employee, nothing to do with them, except I knew one guy a little bit, go over and tell them what to do. I kept my mouth shut. I just carried on doing what I'm doing, about maybe 30-40 feet away from the wires. And with my back turned, the next thing I hear is somebody yell. And I'm not going to imitate it, because it was a big screaming yell. Somebody walked over and they picked up the ends of the cable. How close did that guy come to killing himself? Probably really close. So, yes, the charge is not in the plates, it's in the dielectric. I won't go any further than that. You know, there's all kinds of resources all over the internet. You can read up on detail on all these things. That's what I imagine people are doing when they're watching me work. I sort of poke around with a certain area, make a few comments. Curiosity goes up. Go find out on the internet. So okay, so I just wanted to dwell on that because there is a danger. In fact, can you believe it? Let me show you this. This is the bag of capacitors that have come out of this radio. This one here, I did the insulation test on using my tester. I don't know what I tested it to. Maybe I went to 250 with that one. 250. Took it off the tester. It retained some charge. It sat here on my bench for 3 days. I picked it up, and I think I was retesting it. I can't remember now, but it became obvious. I didn't get a shock or anything. Nothing like that. There was still charge in that capacitor, just sitting on my bench. This old guy retained his charge. I have other stories about this, but I won't go into it. I have a high school story about it. So that's the deal on dielectric. You can't flash discharge a capacitor. If it's a little capacitor, it won't matter, right? But if it's a big honker, so someone suggested, if I'm so worried about this coil up here and burning it out again, I am worried about that, why not put a fuse in series with it? So I had a discussion with the owner about that. The owner thought this idea up too. Why not just put a fuse in there? There's a couple of good reasons for not putting a fuse in there, but I won't go into it. And the last comment, and I thank you all for your comments, even if they are a little bit critical. I don't mind. I'm pretty thick-skinned here, so I really don't mind. People misunderstand things. I'm not clear at times. That stuff happens like that. Flailing around. I appear to be flailing around. Well, it's funny. I got some people who say I follow a very, very rigid sort of prescribed course through the radio, and I have other people who complain that I'm all over the map. My own personal feeling of this is I spend a lot of time just kind of flailing around, wandering around, taking the odd test here and there that may not even be indicated, but I'm just curious about it. Because I know at the start of these projects, and in this one, even halfway through it, I'm still making discoveries I haven't found out yet. So how do you find out that a radio is not wired the way it shows on the schematic? How do you find that out? Especially when you start, you have no notion that that's the case. How do you find it out? You stumble into it. How do you stumble into it? You stumble all over the radio till you stumble into it. So sometimes you'll see me do stuff, you might wonder, why would he bother doing that or doing that right now? It's because it's become easy for me to do that thing, whatever it is, right at that moment, and maybe I'll find something. Maybe I won't. In this particular radio, this has been a lot to chew on. There's no doubt about it. This is, I've run into altered radios before. It doesn't happen that often, but it does happen. But in most cases, it's a small radio, so the alterations just can't be that big, right? But this is a big radio, lots of alterations in it. And are there more to find at this point? I'm going to guess no, because I just worked my way through this thing component by component practically. Well, we don't know what's going on with this switch. The switch appears to be funny. I don't know. Short wave band doesn't seem to come in. Is it because of the switch? So you see, there's lots of potential for more flailing. So if you enjoy the flailing, more is coming. more flailing is coming. So, but no one has given me any hint on what I should do next, except a comment that I should not be so worried about burning the coil out. I think that actually came to me in an email. So why am I so worried about burning out the coil, even if it's very unlikely? For instance, the old coil may have failed, not because it burned open, but maybe because it corroded open. So that's not going to happen again to the new coil. So why worry about it? I worry about it because I don't know what happened to the first coil. And that's why I sit here and make up stories. Some of you enjoy that, some of you don't enjoy that. I make up stories because sometimes, just through imagination, you can get somewhere and realize something that you wouldn't get to without traveling through your imagination to get there. Something worth finding out or thinking about. Okay, oh my gosh, now what? That is the question. Now what? So I'm going to stop for a minute and calm myself down. Because reading comments disturbs me emotionally. I mean, it doesn't disturb me in a bad way. It just gets me all revved up, and so I got to unrev. I need to unrev. How about some coffee? Okay, yeah, I calmed myself down by watching the news for a bit. Holy smokes! Hey, we're halfway through our election here in Canada. Just have another about 10 days to go, I think, and then we vote, and we get back to our regular lives after that. So, okay, this part of the circuit is missing in here. I think the general consensus in my head is the best thing I can do is restore it back to what it was, just as it shows on the schematic. So, where are all those parts going to go? Good question. I think I'm probably going to get I think I may be able to build the entire missing circuitry parts on a terminal strip, and I may be able to fit the terminal strip under this nut here, just so I can build the circuit, put it in there, wire it up all at once. That's one approach. Another approach is bit by bit, step by step, build this circuit in such a way that I can test it as I'm doing it, and each step should show some kind of improvement, and just go step by step. So that's another approach. So for instance, I'd put in this capacitor that's missing. I'd figure out where to establish this resistor which is missing. I'd find the connection from here over to the grids which is missing. Sort all, I could do all that and still have done nothing else. Then I could change this wire to the 56K. This is making more sense to me now. Do this step by step. Then once I change the wire to 56K, there's until this resistor is put in place, this circuit just can't carry much current. I could get all the way there. Then it's just a matter of this going in. I gotta think some more. I gotta maybe I build it step by step on a terminal strip. I'm gonna need terminals. Pretty sure of that. Okay, a little more thought. Where's that coffee? Okay, well, the coffee seemed to work because what came to mind was another possibility, that in fact the original radio circuitry in the radio does not match this schematic that I have. And I know it doesn't match right in the area I'm working on, because on the schematic it's shown that there's a jack on the back to plug in your phono. There is no such jack here, and I don't think there ever was. I don't think it's missing. And this shows two shielded wires essentially traveling to the back of the radio. This would be on the back of the radio. Those two shielded wires. Here's two shielded wires here, exactly as kind of shown, but they don't go to a terminal. They go up to the volume control up here. They're just the audio being shielded, so it doesn't pick up noise and hum in that. So this is no accident. These are all soldered in place. This is original. This hasn't come or gone anywhere. So the radio that's here doesn't match the schematic exactly, and it's pretty close to the area I'm concerned about. So I'm going to study this a little more and see if maybe some of these components were in the radio because of the phono connection, and that's part of why they're missing. They aren't missing, they just never were here because the radio is actually different. I gave a little bit of thought about that. I still got some coffee in my cup, so I'm going to go work on that too. That only took like a minute of looking at this schematic to realize there's a switch shown here, which is not in the radio, to turn on the phono input. You throw the switch, you basically open any signal coming from the radio and just leave it open on the end of this wire, and then the entire signal entering the radio from here through the volume control is from the cartridge, and the far side of the cartridge is grounded to the chassis. So all these components are disconnected when the phono option has been turned on. So none of these components have anything to do with the phono. They all have to do with the radio. So I'm back to square one again. Looks like they all need to be in there. Okay, that's enough for that. But I think I'm going to start actually doing something to this radio here. Still got to decide exactly what. Okay, so I've gathered up the parts. Just five parts in the end. It seemed like a lot more. Got a terminal strip I'm going to install. I got a place I can install it in the radio right where it needs to be. That's great. I sort of mapped out the arrangement of the components, but I won't follow this map exactly. But this gives me enough insight as to how to figure out how to attach these conveniently. Look at this great big capacitor. So I will work on that. I'll get all the components on here. I think this is going to be a one fell swoop repair. I'm just going to put all the right parts in the right place as best I can and turn the set on. I think that's where I'm heading with this. So the next thing I'm going to do is I'm going to build the parts onto here. Okay, so I've got the parts on here, not quite the way I had them drawn, and not not soldered yet. So the ground terminal will be this. I'm also going to solder a wire from the ground terminal to a chassis soldered ground terminal. I've got one capacitor I need to move up here in the radio. This guy's going to have to be lifted and attached to this ground terminal. This guy's going to fit in here. All these wires that have come from the new coil that are just bunched up here, I've got to lay them all down flat somehow, get them out of the way so I can screw that right down solid. Then the AVC out, I could pretty much move this magic eye wire, probably maybe even leave the resistor here for now, attach it onto the right terminal. So, written down here, AVC out, and the IF lead to the IF transformer here onto this terminal. And the AVC out challenge is out to where does this actually connect in the radio, since this connection appears to be missing. So, and I'm thinking, you know, now that I have these on this, maybe this is the way they looked in the radio, something like this. Maybe a terminal strip was sitting in here somewhere, and when this coil change was made, the terminal strip was removed, for some reason not reestablished. And I'm still really curious about what was done to this radio and the why part of it. Maybe it's as simple as the guy didn't have the parts necessary. Maybe he took out the old parts, you know, resistors and that, and he just, considering the capacitors he used here, maybe he didn't have the resistors to do this. I don't know. So the plan then now is to solder this up, bolt it in, wire it up, turn on the radio, and stand back and see what happens. Okay, that's pretty straightforward. Sure sounds that way anyway. Okay, let's solder up all these connections here. This terminal here is where the AVC lead wire will go. This big one here is the ground terminal. Oh, there goes my solder. Okay. So still got lots of challenges here about where to connect this, or a challenge anyway, where to connect this, where to make the AVC connection. Okay, that's every one of them. Good. Now, next thing is to put that into the radio, and what I've realized is the screw I hope to put this on, which is holding the IF can up above. I don't have to loosen the can, I can just fit this right on top with another nut, and that'll be the connection. I'm not going to rely on this as the ground connection. I'm going to run a wire from this post over to a solder to the chassis ground point. I also have to move this capacitor here. Okay, I think I got it all straight. Well, stuff has a way of happening while you're working here. Let me just show you the not so difficult but funny situation here. I was fiddling around with a nut and I dropped it. And you can see it just sitting right there. I mean, that's just sitting there. Look at how close it came to just dropping into the can there. Oh my gosh, if that had happened, I don't know how I would get it out. Oh. Oh, did I just knock it in there? Nope, there it is. There it is. It's right. Oh well. I'm gonna get it. Okay, now I am actually fishing it out of the can because yes, I knocked it into the can. So I think I can hook it with this piece of wire. Man alive, you know, sometimes when you think about something going wrong, I think you almost generate it at that point. Just don't think about things going wrong. Think about them going right. Oh, yeah. Oh my gosh, I got it. Okay, that minor thrill is over now. Okay, I found the nut, a nut that will fit on that. Now I just got to make sure there's enough clearance here to tighten it up. Sure, yeah, no problem. Brass nut. So the plan now is to fit this guy in here, something like this. Let's see. So first of all, you know what? I can get rid of this wire. I know where it goes. I'll just cut it at the resistor. Leave the resistor hanging there. Okay, you're out of the way. This capacitor I plan to reinstall, so I'm gonna nip it off there. That's the ground. Okay, we'll pull that back. And we got some wires kind of in the way here. Normally these wires would be laying quite flat on the chassis. So I'll do that. I'll push them down there. There, that clears the deck. Enough? Enough? Well, there's lots of room in there in different angles. How about this way? No, that's no good. Gotta go in this way. Okay, let's see if I can get the nut on there without dropping it again. Just like that. Now, see if I've got a good socket for it to do. Really close to this resistor here. Well, it could sit just like that. Good. Tighten it in. There it is. Parts are in the radio. Now we just got to hook them up. So I think what I'm going to start with is the wire for the coil. Now the wire from the coil right now makes the connection right here. This black wire. So this black wire needs to go to the short end. So the short end is here. Is that right? Yeah, short end here. So it needs to attach here. That's pretty easy. Just nip it off here. Oh, this doesn't work so well on this kind of wire. Off there. On the end. Might be able to get in the hole. solder that before I forget. See, I'm starting to rush because it's getting late in the morning. It's a beautiful, beautiful day. We got 3 beautiful days coming. We had a beautiful day yesterday. What am I doing in my windowless shop here? There we go. Come on. Let's take a close look at that. Second here. It's this connection right here. Ooh, well, yeah, I need a lot more solder on that. The wire didn't take it all. I guess I didn't get any heat right on the wire. That's probably what happened there. Okay. Probably was soldered, but just barely, that's the thing. There we go. Maybe I can get it underneath here. Okay. That's got it for sure. Now the next connection is out to the AVC, and oh, there's another one too. That's the what? So I have to make the connection to the AVC from the circuit, and then I got to figure out where to put this. Probably in the same spot. Probably. Okay, I'm going to study the schematic for a minute here. Figure out where to put it. Okay, so over here we see R24, and that's on that little terminal strip, and R24 goes nowhere right now. It's just an empty terminal right here. So I have to figure out where it goes from here. So looking at the schematic, it comes over here. So R45. So you got to really wonder what has been done with this. It probably was left connected to a disconnected AVC line. Or were more alterations made to this radio to enable this to work? Good question. So part of it is finding R45. Now here's the VisioGlow tube down here, the magic eye, and it shows the connection at the same point. But it could be connected physically anywhere on this wire, including right to the end of R24. It could be. So that actually, you know what? That actually answers this question. Where's this wire go? Right there. Now, where does this wire go? Right here. Which is the same as right here, and the same as this. So I have to find this capacitor and know that it's there. C20, let's just check the size of C20 for a second. C20, 0.05. So I've already replaced it. If it was in the radio, it got replaced. If for some reason this is not in the radio, yikes. So look, so I got this switch with a terminal, fat chance figuring that out for me. This capacitor, I think finding these resistors is the best idea. Especially this one. This one, wait a minute, let me get it right now, R6. Yeah, it goes up into the switch here. R45. So R45 no, I was going to say maybe connected right to pin 5, but it's not. So I could go pin 5, capacitor, R45. That sounds like the way I got to go at it. Does that say 46? Stop the presses. 45? 46? Uh-oh, stop the presses. Or is that 40?
the presses weren't even running, Jim. 40, it looks like 46. But wait a minute, 46. I thought, what have I got messed up now? 46. Here we are over here. 46. Nuts. So this might be 45. Oh, for crying out loud. You know, I did my best to double check this number because I can see you can't see it. I can see you can't see it. 47. 46. Was the other one 45? This must be 45. Okay, oh nuts. Here. Wow. That sure looks like 45 to me. Okay, R45. I probably made a mistake now in my little. So R45 is 100. R46 is 10. I've put in a 10. Probably where there should be 100. Am I getting this right? 45, yeah. Son of a gun. Rawr. Okay, before I make a mistake on top of a mistake, with the warning of my soldering iron telling me I'm in dangerous territory, I'm going to stop for a bit and just ponder this, because there's been more than one case where I've undone a mistake and just made a new mistake. I'm going to think about this a bit. Okay, so this is the first 6K 6IF amplifier after the RF tube and detector. Pin 5 is here. You see, pin 5 is connected to pin 8, so it is in the radio. And there is a capacitor to ground, this one, which is shown bypassing this resistor. But in the radio, well, I can show you. In the radio, so here's pin 5, and here's the capacitor going to ground. Well, where's the resistor? So we can follow this wire around to pin 8. And there's the resistor right here. Also going to ground. How's that compare? Yes, that's exactly right. So this capacitor is actually across this resistor. Next, we can find this point. So ultimately, I'm in the wrong spot here. I'm in the wrong spot. Yeah. Don't throw me off. So, okay. So we found this. Now we want to find this capacitor. So off of this 5-8 pin combo is another capacitor. Here it is. Coming down to here. Okay, that's getting even a little more interesting now. Where it's meeting a resistor. Looks like 100K to me. And a wire going into a coil. So capacitor to resistor and wire going into coil. So capacitor. Capacitor comes down here, meets the resistor, and a wire going into the coil. So there we are. So that's R45. 40 something, because to my horror, look, there's another R46 in this radio. Man alive. So R45. R45. Yeah, did I say this? As it turns out, I did this correctly. Initially, I got confused in the last little video segment about this. Everything's fine. Okay, 10K there. And R45 is 100K here. So the far side of 45 from the capacitor, that's this terminal here. There's a wire heading up into here, probably heading up for the first 2 tubes on the schematic there, supplying them with AVC. So that's the point. This is the AVC point. So I could connect this wire here. Why don't we do that? I could have connected it over there, but it's getting a little busy over there. So if I connect it here, that'll be AVC to the magic eye tube. And this is where I need to tie a wire now. Wait a minute, do I need to tie a wire from here? No. What am I doing here? So I need to stop and think a bit. If this is the AVC point, it's already tied in. No, I'm all wrong. I'm all wrong on that. Yeah, no. How long have I been in here this morning?
So I think I need to tie the AVC terminal, which I believe is this one here, right to there. Isn't that a scary thought? So I'm going to review that a little bit off camera, just kind of convince myself I got it right. Okay, so I have this terminal on my terminal strip at the end of R24, and all I got to do is hook it up to the end of R45, which I found opposite from the capacitor and where I plan to hook the Magic Eye grid. Exactly like this. Perfect. Let me go do it now. Okay, so I managed to pull this nice piece of vintage wire out of the radio earlier, so we'll use it. Connecting this terminal to this terminal. And then, am I crazy? This thing's ready to test after I do this. Yeah, the answer is yes, you're crazy. Yes, sirree. Okay, I'll get this wire installed. Well, I think that's everything. Here's one thing. That's the AVC series resistor, grid resistor, out. I think I've got everything hooked up. I've got the extra ground installed. I moved the capacitor over. I've hooked up this wire here, hooked this up here, and there. And I think we're ready for a test here. Okay, now made an awful lot of alterations in the radio. So first I'm going to clean up my bench here and neaten it up before I turn the radio on. So I'm going to do that. Okay, I think I'm ready to start. So we'll be listening to this through the audio system here in my shop. Okay, which I noticed I've left the volume up on all this time. Not that it would matter. Okay, I've got my headphones on so I can hear too. I made lots of alterations. Did I make a mistake? I can't say for sure, so let's keep an eye on these bulbs. We're going to give it the largest restriction, so that's the smallest light bulb in there. Again, if that bulb comes on full blast and just stays that way, then I've done something terrible in here. What it should do is to come on and go down a little bit fairly quickly. If it does that, thumbs up. Volume level is down all the way. I think we're on the AM band. Well, there. I think that's the AM band. And you know what I need ready here? I need my my temperature measuring device. Where is it? Where'd it go? Okay, I gotta go. Turn it on. I gotta find that. Well, I think I'm ready. Got my infrared viewer here. Just make sure it's on. This is a great thing, man. I use this all over my house too. Can't wait for the winter. I'll be checking things out. So 22 degrees is just the temperature in here. 23, 22. I'm again worried about these resistors getting too hot, and who knows what else might get hot in here. Hopefully nothing. Hopefully nothing. I think we're all set. Well, I didn't hear anybody say don't do it, so here we go. Volume down again. Flip the switch and watch that light. Perfect. Perfect. It may not be so apparent in the camera, but it's quite obvious here. Now I've got quite a restriction here, so there may only be, what is there, 85, it's about 85 volts on the radio right now. Oh, put on your headphones, Jim. What's going on? Quickly, quickly. So I don't have the volume up yet on the video audio system here. Let's do that. We'll turn that up. A little bit, just a wee bit of a hum there. That was up awfully high. So probably the radio's not really operating yet. I got to screw in the next light bulb here. Now I'll just leave the volume up a little bit. Okay, so this should be enough now for the radio to operate. Usually
usually comes out to 100 volts. Exactly. I'm just checking here.
Yep, 99.3 volts. So volume up. Come on, baby. Well, I'm not hearing anything at all. Nothing at all. Okay, quick temperature check. Anything burning up? Now, the temperature has to get very high to show up red here, so I'm going to change this. I'm going to adjust this so it won't take so high a temperature to make it look red. So at 45, we'll see things at red on here now. So it's below 45. Below 45. Now these are high wattage resistors. You certainly expect them to run hot. And you don't expect them to be cool. Over here. Those are all the high wattage resistors you see showing up there. Just fine, in fact. The temperature is fine. Why aren't we hearing anything? Okay, so first possibility is I haven't done the audio correctly here. Just check, make sure everything's switched on. Certainly hear a bit of a hum if I turn it right up. Band switch may not have engaged properly. My clip leads may have fallen off. Let's check that first. That's because the clip leads are kind of hidden back here. Oh, I heard a little clicky pop. Let me look on this side here. Well, I'm afraid that's not... I don't think that's the issue. They appear to be connected. Okay, so I've had band switch antenna. I never hooked the antenna up. That's probably the problem. And I get to use my brand new antenna cord I made the other day. Look at that. Now I got nice clip leads here. So volume down, volume down. Volume's down. You know, these radios can be extremely quiet with no antenna. I can hear it already. What are we hearing there? Let me just cut the microphones for a sec. Okay, so you're actually hearing some kind of noise. Again, it's probably that coil, so I'm kind of hoping that would go away. Quick, anything getting hot in that area? I mean, I can't really. So these are showing up red now. The 50 degrees, I can read it on a little red scale here. 50 degrees. 50. They're still pretty warm. Just took time, I guess, for them to come up. They're all running pretty warm. A lot of these are carrying B plus current, screen currents, and they should be getting warm. But the B plus in here, even though I've got restricted voltage from the outlet right now, the B plus may be a little higher than it would be normal. The reasons for that are I've got a stronger than normal rectifier tube in here, a 5U4, and I don't have the 245s plugged in, which really are going to suck back the B plus. So I think, as before, put the 45s in, everything's going to settle down in terms of voltage. Now, am I seeing a short circuit that I accidentally made? I don't think so, but let me just pull on a wire here, just away from a terminal. So this makes a big noise. No, it was not shorted, just close. Where's the sound? Oh, got the antenna on. Come on, turn it up. Oh boy. Okay, so that didn't produce anything. My antenna's definitely connected. 0 coming out of it. Not quite what I was hoping for. Let's try changing bands here. Maybe I've messed up on the band thing. Volume up a little bit. Band switch. hear things again. I think that's that coil singing. No sound out of that. I don't think we're getting a sound up here. These are the short wave. This is how I believe this works. That's short wave. This should be AM here. And tuning. Oh, it does something. So maybe it's there, it's just ridiculously quiet. Scary business. What can we see on the magic eye? Oh, the magic eye is glowing there. It's just really hard to see. So I want to watch and see if the magic eye operates at all. From here as I tune this. Oh yeah, you see that? So what may have happened here is the radio just may be so badly tuned now, front end, IF, everything, that this is definitely moving. So that's a really good indication. I think our next stop is going to be a full-blown alignment. We'll repeat the IF alignment and then carry on with the front end alignment. And see if we can't bring this thing back to life. I think that's actually a good result so far. Nothing's on fire. And the magic eye seemed to react a bit. And that same reaction on this eye is being applied to the tubes that need it, at least. I'm hoping that's what's happening. But I think this is as far as I want to go today, because it's a beautiful day. I'm going to get outside. And tomorrow what we can do here is take a closer look at voltages and signal strength and all these other things, and fiddle around with the IF tuning. You can do a rough job and see if that in fact has been knocked off. I think there's a suggestion one of the capacitors I put in earlier has knocked it off already, or maybe that was during one of my experiments. So very good though. I think that's, the world has not ended, and I think that's good. Good for me anyway. Thanks a lot for watching, and I'll see you tomorrow probably.